So we know how to add and subtract. So we know how to add two decimal numbers. So if we want to add 81 plus 33, we will simply do this. But if a computer wanted to add them, it would have to have the binary equivalent of each number, which means we would have to convert 81. You would have to convert 81 from base 10 to base 2. And we would have to convert 33 from base 10 to base 2. So let's start out with our headers. So 2 to the 0, 2 to the 1, etc. 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7. Same thing as 1, 2, 4, 8, 16, 32, 64, 128. So let's start with 81. What's the largest number that's less than 81? It's not 128, so we set that to 0. 64 could go into 81, so we subtract 64 from 81. That gives us 17. 0, 1 minus 16 is 1. So we set 1 to 1, and everything else to 0. Now for 33, we set 32 to 1, and we set 1 to 1. So what you want to do is you want to add each bit. So when you have 1 plus 1, that evaluates to 0, and you carry the 1. 0 plus 0 plus 1, 1. 0 plus 0 is 0. 0 plus 0 is 0. 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 0 is 1. 0 plus 0 is 0. So this evaluates to 64 plus 32 plus 16 plus 2. Which is the same thing as 114. Now if we wanted to subtract two numbers, say we would have to add a negative number, because subtraction is the same thing as adding a negative number. So if we want to subtract 74 from 81, we start by finding negative 74 in binary. So how would we represent negative 74 in binary? Just as a reminder, 74, positive 74 in binary would be equivalent to 0, 1, 0, 0, 1, 0, 1, 0. So your first assumption might be that we need to set one of these bits to evaluate as a sign. So let's say we set the first bit to 1 to evaluate negative. This method of representing negative numbers is called sign and magnitude form. Okay, this doesn't actually make it easier to add 81 and 74. So we're gonna use a different way to represent negative numbers called 2's complement. So to start, we take the positive binary and then we convert it to 1's complement form. And after that, we simply add 1. So let's start off with 0, 1, 0, 0, 1, 0, 1, 0. So to convert to 1's complement form, we simply flip each bit 1, 0, 1, 1, 0, 1, 0, 1. And then we add 1 to convert it to 2's complement form. So 1 plus 1 is 0, carry the 1, that's a 1, 1, 0, 1, 1, 0, 1. Okay, so now I'm going to prove that this equals negative 74. We could evaluate 81 minus 74, the same thing as 81 plus negative 74 in decimal, and we get 7. So if you wanted to do 81 in binary and add negative 74 in binary, we should get 7 in binary. So that's what we're going to do. We're going to start off with positive 81, which would be 0, 1, 0, 1, 0, 0, 0, 1. And we're going to add to that the number we got here in 2's complement form. 1, 0, 1, 1, 0, 1, 1, 0. 1 plus 0 is 1. 0 plus 1 is 1. 0 plus 1 is 1. 0 plus 0 is 0. 1 plus 1 is 1. A 0, carry the 1. 0, carry the 1. 0, carry the 1. 0, carry the 1. So something you'll notice is that we ended up with 9 bits, but we only care about these initial 8. So we will just ignore this one for now. So we just evaluate this, which is equal to the 0 power plus 2 to the first power plus 2 to the second. It's the same thing as 1 plus 2 plus 4. This is the same thing as 7. So as we see, 81 plus negative 74 is equal to 7. So now we're going to be converting from 2's complement to decimal. This is a useful thing to know. So we're actually going to start off with these two binary numbers, and we're going to convert each one to decimal. So one thing you'll notice is that if the most significant bit is 0, that indicates it's a positive number. The most significant bit is a 1, that indicates it's a negative number. So for positive numbers, we're going to do what we've been doing earlier, which is just evaluate to binary. This is going to be equal to 1 plus 8 plus 16 plus 32. That equals 257 base 10. However, for negative numbers, we're actually just going to find the positive version. And to do that, we're going to perform 2's complement on this number. So let's start by flipping all the bits to find 1's complement. So this is 1's complement. And now we want to add 1, which is 1, 0, 1, 0, 0, 0, 1, 0. And if we add these bits up, that's 1 plus 4 plus 64, which is equal to 69 base 10. So what this means is that the positive version of this byte here is 69, and since we're looking for the negative version, we would say 1011 1011 base 2 is equal to negative 69 base 10.